So, you guys ready? We are going to be doing even more of our stargazing. Get out your pencils, get out your questions that you're going to type into us. We are ready to bring on our main feature for tonight. And let's see if I can find him. Kent, where are you? Are you here?
I'm here. Yeah.
Woohoo! Welcome, Kent. So Kent
Thank you.
yes, thank you so much for being with us. Now, Kent is, I don't even know how to describe it. He's just amazing. And when I first started in astronomy, maybe 15 years ago, I would park myself next to him because he's the type of person who you can ask any question to, like, what about this and what about that, or where do I look here? And he's like, oh yeah, you look over here, and he's just this incredible wealth of knowledge. And I wanted to be able to give that resource to you so you can have that too. And so I'm really excited. Go ahead, Kent.
I wanted to thank Brian for the comet thing because I've tried to see it and haven't had any luck.
Awesome. Yes, quite a few people are saying thank you so much for the comment. So thank you. All right. So Kent, tell us really quickly before we get started, what kind of telescope do you like to use?
The easiest is my old C8, which is a Celestron 8-inch Schmidt-Cassegrain.
And let's see if I can find a picture. Oh, there you are. And so you just got started with a little telescope like this?
Actually, I started with a Sears 60 millimeter refractor.
Oh, that's right.
Back in about 1969 or 70. And that's the beast there, the 20-inch.
Mm-hmm. Nice. So, Ken, what do you really like to look at when you go stargazing? What is your personal? Give us a little background about yourself before we dive into stargazing for tonight, so folks can get to know you a little better.
Oh, for tonight?
Yeah.
Other than the comet, which I'll probably go out with my binoculars around 9:30 and see if I can see it, would be Jupiter.
Mm-hmm.
Jupiter, and then Saturn is about a binocular field to the east from those. So those would be the two I'd start off with, is Jupiter and Saturn, just because they happen to be over into the southeast now.
Got it.
So those would be the two I'd start with.
Okay, great. So for those of you who may be wondering, why am I just showing pictures of Kent and why can't you see him? Kent is on a rotary phone. And so it's a little bit of a trick to get this connected, but we did it. We're very proud about that. And also, Kent is using his knowledge from his head. He's not looking at star charts while we talk. He's actually going to be just sharing his wealth of information with us. And then I am going to be using the planetarium software that is free and available for everyone. It's called Stellarium, like stellar, Stellar, and then IUM, Stellarium. And so I'm going to be navigating that. So he's going to be talking to you, and then I'm going to drive the controls for the planet. It's like an indoor planetarium. And I'm going to drive the controls so you actually see where to look. And we'll be going back and forth with images and so forth. So are you ready, Kent? You ready to start? We might as well start with the ones you mentioned.
Yeah,
are you ready?
Let's get going, yeah.
All right, let's do it. Here we go. Okay, so let me share my screen. And Kent, why don't you get started talking and tell us what we should be looking at tonight?
So for constellations, I figure, start with Libra, which is down south. And that's that one that has the unpronounceable names for the alpha and beta stars.
Yes.
It's Arabic, and I think it's like Zubeni or something like that. But, best to use alpha and beta. It's a lot easier.
Yes.
And one means the alpha is a southern claw, the beta is a northern claw. At one time, the stars that make up Libra, or the scales, were the claws of Scorpius. And it was the Romans who sliced it off and made them the scales, kind of shortened down poor old Scorpius there.
Yeah, and so for folks that have maybe never aren't familiar with stellarium, what we're showing right now is the night sky. You can see the Milky Way band here. This is only something you're going to see with really dark skies, not in a big city like New York. But this is a really dark sky right now that I'm showing you, and it has a lot of stars in it. And if you look at the little red compass headings here, this one says south and this one says southwest. So from the northern hemisphere tonight, if you walk outside and you look between south and southwest, and you look straight up, you will see, well, you'll actually probably see this big star first. People sometimes think it's Mars. It's not. It's Antares. That's part of Scorpio. We're going to talk about that. But the constellation we're going to focus on right now, you see this diamond pattern? Okay, so that's Libra. Now, normally, you will not be able to see the dots connected, right? Or the names. So let's do this without any of the fancy stuff. Typically, you're going to see this. And so this can be really confusing. Like, well, how do I know what I'm looking at, right? So, and I look around and just more dots, right? Okay, so this is how we're going to do things. So we're going to look for certain, signposts. We're going to look for certain familiar patterns that you'll be able to pick out. And this is true even if you're in a city. So you're going to go outside tonight from the northern hemisphere. You're going to look kind of due south, and you're going to look straight up over the horizon. And you're going to see a really bright star. So that's going to be Antares. It's going to have kind of an orange-red glow. Would you say, Kent, more orange or more red for Antares?
Yeah, orangish color. It's, it's relatively bright. It's a first magnitude star.
Yeah, it's really bright. So
and Antares is really big. I mean, it's, I think they were saying it was something like 4 astronomical units in diameter, so
wow.
That would put it out there a ways. Actually it's 4 in radius. That's right. So it'd be 8 in diameter. So its surface would be probably in the asteroid belt, beyond Mars.
So if we replaced our sun with this one, the sun would be all clear out to the asteroid belt or further.
Yeah, Antares, the surface, it's like 600 light years away, so it's way out there.
Wow.
And it's what they call supergiant M-class star. And, it's red, but it's really bloated.
Yes.
And, it kind of falls in the category of going to go supernova someday. But the thing that's amazing is how the constellation of Scorpius actually looks like a scorpion, the shape of it.
It does.
Antares, they call it the heart of the scorpion, but the Greek, it really means like Mars. It has a reddish color or orangish color like Mars. And so it, translates like Mars or like Ares.
Right.
Or Antares. Ares is the Greek god of war. And so that's where it comes from, is the Greek.
Perfect.
And, that's basic how the thing goes. There's a story. I guess we should get the mythology.
Well, wait. Hang on. I was just going to do a signpost. Wait, don't do the mythology yet. Hang on. Let's.
Okay, no problem.
Okay, wait.
No,
I want to hear what you have to say. Let me finish this really quick. So for people that are new, when you go outside and you look between south and southwest, you'll see a bright red star, orange star, and you'll also see a little bit lower, like a whitish blue star. Okay, so this is going to be Spica. This is going to be Antares. So if you look here and I connect the dots, do you see where the diamond is? Do you see that's between the two of them? This is the constellation we're going to be talking about first, and then we're going to talk about this constellation over here, Scorpio. So if I turn this off, can you find it? Can you find that diamond? Here, I'll turn it on again and turn on the names. We're looking for Libra. Libra is this one. Okay, so when you go outside tonight, here, I'll shake up the sky a little bit. There we go. Okay, you're going to go out, look between south and southwest, find a bright orange, a bright white. These are going to be the brightest stars in the sky. Look in the middle. Can you find the diamond? Can you get it? Did you get kind of close? The stars are not very notable in Libra, are they, Kent?
No, it's kind of a sad constellation. It's really not one that, it's got a few faint objects in it, but it doesn't have any nice binocular objects in it.
Okay, now
but
go ahead.
I was thinking also for showing the scorpion there, another big way of finding it is look at the Milky Way. It goes right through. I mean, you can't miss the Milky Way if you're somewhere dark. And it goes right through the Scorpion there.
Perfect. Yep. Now, can you find the Scorpion? You see the bright star? It's due south. You're just going to look up. You're going to find Antares, which is that bright orange star. And then you're going to look for a kind of a backwards question mark. Not like Leo the lion, but this one is lower in the horizon. That's going to be the tail of Scorpio. Okay, so Kent, you want to move on to Scorpio, or did you want to mention any more things about the...
Let's, you know, the thing that's neat about Scorpio is or Scorpius, is it really looks like a scorpion. In fact, those two little stars at the end of the tail are the stinger, or is the stinger. Also, there's a, you know, when you make that first drop down and you make the first curve, there's the false comet, which when you look at it with binoculars, it really does look kind of like a comet. It's just a grouping of, actually it's an association of stars in there. And you can see it right at where the first curve begins down there. They call it the false comet, or also I've heard the name the table of Scorpius, believe it or not. And there is a really nice, not binocular, but telescopic cluster in there. I think it's 6231.
Yes. Oh my gosh. Yes, you're right. Here, let me highlight it on the window.
6231. There's a very tight, very young, you know, really nice cluster in a telescope. You're going to see the false comet in binoculars, but that cluster, if you get a nice telescope on it, even a small telescope, it really is pretty to look at. And so that's, you know, that's a nice thing about the false comet. And then I always like the stinger at the end of the tail of the Scorpion. That's always kind of cool to have those two end stars there. So it really does look like a scorpion. There you're getting it. Now, it's a really young cluster with a lot of bright stars. And in fact, you can see that H2 region up above, that red region. That whole area is a what they call an association of stars. It's got a lot of very hot, very bright stars in it.
Awesome. So you mentioned H2. Did you want to talk about that for a minute?
Okay. H2 means singly ionized hydrogen. When you see the astrophotos that show red for a nebula, that's the ionized hydrogen in most respects. And you can see a few of them. In fact, I've already blown it up there where you can get that nice little H2 region there. And our eyes see it, or actually the film sees it best as a red nebula. But it's actually, the reason they call it H2 is H1 is neutral hydrogen. It has its electron. Where H2, actually, the electron's been knocked out. When it drops back in, it gives you red light. And so that's how you get the red nebulosity.
Right. Okay, perfect. Thank you.
Oh, you're welcome.
Okay. So let's see. We talked about Antares. Did you want to talk about M4 since we're...
Yes, let's talk about M4 because
Okay.
it's real easy. Once you find Antares, you can find M4 quite easily.
Yes.
Because it's got that. It's just to the west and down to the south just a little bit from Antares. And so it's a pretty, once it gets dark out, it's pretty easy to pull in. Plus, it's the nearest globular cluster out there. And so, you know, it's nice to have something in close. It's only 5,600 light years away. So it's pretty close.
Mm-hmm.
In fact, you should be able to see it there. I think I see a fuzzy spot just over from Antares.
Give it a minute. I think you've got another delay on your end. I don't know if it's internet speed or what, but I'm keeping up with you. It'll show in just a minute.
Oh, okay. Yeah, because right now I'm seeing an image of the whole constellation.
Okay, let me see if I can get
And
another picture.
there it is.
You see it?
Yeah, yeah. It's a nice globular cluster. It's easy to find since it's just over from Antares. It's a real easy one.
Mm-hmm.
And it's our nearest one. At, being only 5,600 light years away, that's, pretty close overall.
It is. Now, this is
And
something you can see with binoculars?
Oh, definitely. Yeah, yeah. It's an easy binocular object.
Okay. Awesome.
It's magnitude 5.9. I'm sure there's some eagle eye people out there that have probably seen it naked eye before.
I'm sure it would not be me. Well,
yeah, my eyes aren't that good, but there are a few people with really good eyes out there. But the average person, just get a pair of binoculars, 750s, 1050s, and that'll work out pretty good.
Okay, great. So tell me about the butterfly. Oh, I'm sorry. Go ahead.
Did you want to talk about the difference between globular and open clusters?
Oh, yes. Thank you for reminding me. What's the difference?
I mean, there's a big difference. Is globular clusters are really old, 10, 11 billion years old. They're also very rich for the most part. There's, 100,000 stars on the average in them or more. Where open clusters are usually in the disk of our galaxy or nearby. They're formed in H2 regions, and like the Orion Nebula or the Pleiades is an open cluster. Eventually they get tore apart, so it's hard to find an open cluster that's 1 billion years old.
Perfect. Yeah, I've got a picture here from Astronomy Magazine about an open cluster here and also a globular cluster, NGC 104.
Yeah, big difference between the two, and 104 is like the showpiece.
It is.
That's 47 to Canada. That's kind of like cheating,
I thought you'd appreciate that.
Yeah, that one in my 20-inch just really blows my socks off. It's a awesome object to see.
Yes.
But you got to be down in the southern hemisphere because it's right next to the Small Magellanic Cloud.
Yes, I wanted to bring that up because we have a number of people from Australia that are on tonight. So that was just for them.
Oh, cool.
Okay, so let's get back.
I was observing from Western Australia and had a great time down there.
That's right. Kent actually brought his telescope down to Australia. How many times did you go?
The 8-inch I brought once, and the 20-inch I air freighted down there 3 times. So I've made 4 trips to Western Australia.
Wow, that's awesome. Okay, so where were we? We were talking about, how about the butterfly cluster? Is that a good one to bring up?
Oh, okay. Actually, next in line really should be M7.
Oh, M7.
Remember the pointers on the Scorpion? They pointed M7.
Yes.
M7's a cool open cluster. Beautiful binocular object. It was found a long, long time ago. Ptolemy was the first guy to catalog it in, I think, 130 AD. He put in his catalog of fuzzy objects. You look at it, you can actually see it naked eye. It does look kind of fuzzy, but in binoculars, M7 is really nice, and the stinger of the Scorpion kind of points at it roughly. But it's really a nice binocular object, not so great in a telescope because the field is limited, usually through the eyepiece of a telescope. But for 750s, 1050s, it looks really nice. And that's an easy one. And I guess next we can go to M6, which is the butterfly cluster.
Okay, which is right next door. Yep, I've got it highlighted here.
Cool, yeah, you've got the brackets on it. And it's about, M7 is about 980 light years away.
M7 or M6?
M7.
M7, okay. So Ptolemy's cluster.
Yeah, M6 is up a bit further and a little bit west from M7. It's also in Scorpius. It's fainter. It's magnitude 4.2, where M7 is magnitude 3.3. But it's a nice binocular object. I don't think it's a naked eye object. But it's just a neat little open cluster, and its real claim to fame is it's pretty close to the center of the galaxy.
Yeah.
The actual center of the galaxy is about 3 degrees north and a little bit to the east.
That's awesome.
And unfortunately, there's nothing cool marking that.
No, there
There's
isn't.
there's so much gas and dust and junk in the way that it takes like infrared or radio waves to actually look towards the center of our galaxy.
Yeah, it does.
But
There's just so much stuff in the way.
But if you're looking at M6, you're pretty close to the center of the galaxy.
Mm-hmm.
It's just a little bit further north and a little bit east.
Perfect. Did you want to talk about the pipe?
Yeah, the pipe is cool. We didn't get around to it last month. It's actually above the back of Scorpius, and it's actually kind of in the feet of Ophiuchus, who we talked about last month. But it's a really nice binocular object. It looks like a black pipe in the sky. It's actually a dark nebula. Most of the darkness is caused by big clouds of carbon dust. Regular giant stars in their evolution will produce a lot of carbon, and they puff it out like smoke, and then it drifts around and clumps together and forms dark nebula, and eventually probably will form some brand new stars in that area. But the pipe is real easy to see. It's got the stem, and then it's got the bowl is to the east. The stem is to the west. You can kind of see there's like an outline of stars along in there, right along like the stem of the pipe there. And I get the feeling that the dust is blocking other stars that are, behind the dust cloud. And I was trying to find a distance this afternoon, but I couldn't find a good distance to the pipe. It's also called Barnard 78, I believe.
Yes, that's right.
And you can see a bunch of dark nebula around that general area. There is a lot of dusty nebulas around that central area there.
Yeah, it doesn't look like much on Stellarium. Go ahead.
Oh, it's just such a cool object to sit. I remember many a time I'd sit back at Navajo Flats, and I could easily see the Pipe Nebula with my 750 binoculars. Some people have seen it naked eye.
Wow.
Yeah, if you got a really good dark area and they got good eyes, they can pull it out naked eye.
Wow, that's amazing.
Yeah. For me, that never happened. But the binoculars really help.
They do. Kent, we got a number of questions that have been coming in. Apparently, Brian's been flooded. So before we hit the next constellation, do you want to take a few?
Sure.
Okay, great. For the folks, I think I neglected to say how you can ask questions. You can use the chat box, or you can use that little thing underneath me. It says questions. You can actually text Brian at that number. Don't call him, just text him your question. Or you can email it to questions@centralcoastastronomy.org. So folks that are watching us on a television, like a smart TV or something, you can those are options available for you as well. Okay, Kent, here we go. Hello, thank you so much for tonight. They are wondering, I don't have a name with this person, will I be able to see the rings of Saturn using 8x40 binoculars? And do I need a tripod?
Tell you the truth, with my eyes, I can't see the rings in 8x50s. So you probably won't see them in 8x40s. You might notice there may be a little bit, if your eyes are really good, you may be able to see a little bit of, that it's like a yellow star, but it'll have a little bit fatter in one direction. So you might be able to pick that up, but I don't think those are good enough to actually see rings.
Yes. Okay, great. And Laura is asking, how do all the parts of the sky scanned by? So how? Basically, the question is, how do things like Stellarium get their pictures, get their images? And you actually know a little bit about this, don't you?
You mean, okay, yeah, the online atlas, those guys must have enormous, it's going to take a lot of programming to actually put in the pictures and everything to blow them up. There's got to be a lot of files sitting back there just waiting for deep sky objects. So, it's some really smart people with programming that actually set up something like that.
Yeah, and these are real pictures. These are not artists' images and paintings. These are real photographs that have been taken by scientists.
Yeah, actually, if you go on Google and put in like a Messier, go, M7 or M8, there'll be a ton of pictures that amateurs have posted out there that'll pop up for the various deep sky objects. So I'm sure the guys that put together these programs go and look at these various pictures and get permission from the photographers or the imagers. I think everyone's an imager now since it's all digital.
Yes. Okay, great. Thank you. Two more quick questions. Let's see. How do stars get their name? This is from Leah.
Oh, the brighter stars, it goes way back. It turns out a lot of the stars have Greek names, and there's really old names that go back to the Babylonians and things like that. Everyone had different constellations and different names for the stars. What we deal with today are mainly Greek constellations that the Arabic civilization at that time preserved the Greek astronomy works. And a lot of the stars have Arabic names to them, and we just carried them on. I think when they stole the libraries in southern Spain and translated them from Arabic into Latin, they just carried on the best pronunciation they could with the Greek language. So we got some really weird names for stars like Betelgeuse, the armpit of the giant, or Deb Nola, the tail of the lion. There's a whole mess of Arabic names. So I bet you most of the bright stars, or ones you can see naked eye, have multiple names.
Awesome. Thank you. Let's see. We have a number of people asking, can you please finish the Scorpius myth before we move on to the next constellation? Do you want to tell us a little bit about the mythology?
Oh, pardon? I'm sorry.
That's okay. The mythology of Scorpius. Remember I cut you off there?
Mythology, sure.
Yeah.
Sure. In fact, yeah, that's something I'm glad they brought it up.
Yes. I wasn't going to let you...
I almost forgot about it.
It's okay. I wasn't going to let you forget, but I'm glad people are on it too. Go for it.
Yeah, I mean, there's all sorts of legends going way back. I remember seeing I think it was a carving of the zodiac out of Egypt that goes back, 5,000, 6,000 years. I mean, it goes all the way back to before the pyramids. And, they still had the scorpion there. So there's, almost every society had their legends. But the one for the Greeks has a legend that starts with Orion, which was also considered, Achilles at times is used rather than Orion. But he did some bragging about what a great hunter he was, and eventually got under the skin of the gods. So they sent a scorpion to sting him in the heel. And, of course, he died. And, usually after the gods kill someone, they feel bad about it. So they put Orion up in the heavens, but also they put the scorpion in the heavens. But they put them on opposite sides of the sky. When the scorpion rises, Orion's already set. When the scorpion sets, then Orion comes up. So they never meet, always being opposite sides of the sky. And the interesting thing is there's one other Class M supergiant. It turns out it's Betelgeuse in the shoulder of Orion. And so Scorpius and Orion have the two M-class supergiants.
Perfect. Awesome. Thank you. Okay, so let me get back onto the other part of the world. I was showing Orion while you were talking. Okay.
Oh, okay.
Okay, so we have Scorpius. And what else is great to look at tonight?
We got to hit Sagittarius.
Yes. And what does Sagittarius look like to most people? Whoops.
It looks like a teapot.
It does.
Do you remember how we talked about the teapot with the handle, the body, and the spout?
Mm-hmm. Yep, that's
that
it
one
right
would
there.
be good. You know, and the interesting thing, if you look at the spout, the Milky Way goes right up through it, and that's the steam coming out of your teapot. So it's, I definitely have a delay with the graphics.
You do. I'm sorry. We tried to fix that, but apparently we didn't do a good job.
But,
that's okay. Here,
we talked about the teapot. So the first thing you notice is the handle. Those 4 stars that make up the handle of the teapot, and then you've got the stars that make up the spout, and in between is kind of like the body, with one star kind of up above, being like the top of the teapot or the the cover of the teapot. So it does kind of look like a little teapot there.
Yes, it does.
In truth, it's a centaur with a bow and arrow, and it's referred to as the archer in all sorts of mythology. And but the teapot's easy to show people, and you can also show them how the Milky Way is kind of like the steam coming out of the teapot. And that's the top of the handle, or not the handle, the lid there, that one star you were circling. A lot of times people use the teapot.
Perfect.
And I guess before I forget about it, I should talk about the mythology of the archer.
Yes, please do.
Being that there's, again, a lot of different myths and things like that, but one of the Western myths ties in with another centaur. There's 2 centaurs in the sky. There's a constellation that's way down south called Centaurus, and then we've got the centaur with his bow and arrow in Sagittarius. And the legends go that Centaurus was a teacher of mankind. The god's beloved, his name was Charon. And he taught, like Ophiuchus, which we covered last month, he taught him how to be the best doctor in the world. He also taught humans about astronomy and the constellations. So he put Sagittarius up there to have Centaur in the constellations. And later on, he got put up there because Hercules killed him by accident. Hercules was really good for killing everybody in sight. And he accidentally killed poor old Chiron with a poison arrow. And so that's the old Greek myth, and everyone felt so bad they put Chiron up in the stars, but it's way down south, so it's for the folks in Australia or South Africa or South America. And that's the legend there.
Perfect. Now, we have a quick question that's coming in about Sagittarius, asking what is the tight circle of stars below the teapot? That's from Richard. I think he means... Go ahead.
There is a group of stars which is, you've got the Corona Borealis, and this is Corona Australis, the Southern Crown. I don't know if that showed up on the graphics or not, but that's a circle. Actually, it's partial circle, but it's more of they call it the Southern Crown, and it's in lower Sagittarius. It's like the next constellation down. In fact, there it is, Corona Australis. I can see that curved arc, and it's just below the body of the teapot, and so that's pretty far south. And that's for another discussion, but that's another constellation down there.
Okay, great. Okay, so tell us, what's so great about Sagittarius? Why should we bother?
Okay, there is so much junk. Yeah, I mean, there's all sorts of deep sky objects in both Scorpius and Sagittarius. We're leaving out the telescopic ones for the most part and going for the ones you can be seen with binoculars.
Mm-hmm.
And on your handout, you've got M55, which is a globular cluster, visible binoculars. It's kind of to the east in Sagittarius, and it's a nice globular cluster. I can pick it up quite easily in my 750s when I'm sitting out at Navajo Flats. And it's just, average run-of-the-mill globular, but it shows up good in binoculars.
Nice. Perfect. Okay,
And
great.
let's see, I think it's 19,300 light years away, so it's out there away.
Yes.
But
Okay.
because it's kind of all by itself out there,
Mm-hmm.
it kind of makes it easier for you to pick it up in binoculars. It's away from the Milky Way. It's kind of a sparse region, so it stands out easier to see.
Nice. Okay, so after you found M55, where should we go now?
Okay, the next one's a real fun object called M22. That's kind of near actually a little bit east of the top of the lid for the teapot. And it's interesting because M22 is kind of bracketed by little groups of stars on either side. Mm-hmm. And M22 is also a quite bright globular cluster. One thing I like to do on star parties is I try and get M22 in my telescope while it's still fairly light out, when the stars are just starting to pop in. And when you do that, you only see the red giant. So it actually looks like an little open cluster of red stars. And you can watch them kind of fade away as the whole background comes in eventually, and you can't even pick them up after a while. But for a narrow window of time, you see about probably a couple dozen red stars. It does look like a little open cluster. And so I've only been able to do that using the 20-inch with M22. And I think it's because I read somewhere there's a dust cloud mm-hmm. between us and M22, so that probably reddens those giants even more. Well, also for distance, that one's it's a nearby one, relatively nearby, at 10,400 light years.
Nice. Okay, so we've jumped around to what's next in this area that you would look at?
Oh, let's see. Next is a fun object that's actually naked eye called the Lagoon Nebula, mm-hmm. or Messier 8. You have to kind of slide west from M22 to pick it up, but I can be out in Navajo Flats where it's good and dark, and I can actually see an elongated object, and that's actually the Lagoon Nebula. And the cool thing about Lagoon Nebula is there's actually 3 objects there. So it's kind of like 3 for 1.
Tell us about the 3 objects.
You've got an open cluster. It actually has an NGC number. It's 6523. Very young open cluster. And then there's just over from it, there's a dark lane. It's a skinny, long, doesn't have a Barnard number to it. Probably because they included it in M8. Mm-hmm. But it's, some people say it's the entrance to the lagoon. You got the dark lane, and then just beyond that, you have a bright H2 region where stars are being born, and there's actually what they call the hourglass, a really bright area that looks into the nebula. The Hubble's taken some pictures of the hourglass region, and it's really bizarre looking, like there's kind of like tornadoes or something in there. And you can only resolve it with like using the Hubble to see that detail. But lagoon is a real easy binocular object. You can see it naked eye. It kind of looks like a elongated section of the Milky Way. naked eye. And surrounding the cluster and the dark lane and the bright H2 region is a fainter H2 region. Actually, it's got O3 in it because you can pick it up with an O3 filter and light up that whole area. But if I've got a 2-inch O3 filter, I'll screw into the big eyepiece, and you can see nebulosity all around that area. So it's really a beautiful object.
Wow, that's awesome. Okay, let's give everybody a quiz here. I'm actually going to move the planetarium a little bit, shake it up, and there are no lines connecting any of the dots. So quick, can you find Scorpius? Okay, you want to look south. Here's my south and my southeast. Can you find it? Do you see that red star? Okay, you see that red star? Good, that's Antares. Good, can you find Scorpius? Do you see it? Good. And now, where is the teapot? Can you find it? There are no connect the dot little lines in here because this is what it's really going to look like tonight. Actually, I should turn off the Milky Way, and that's really what it'll look like. Here, we'll turn on the atmosphere a little bit and kind of dim things. There we go. Now, if you live in a city, this is more of what it's going to look like. Maybe a little on a very good night. Okay? Do you see the teapot there? Did you find it? Here, if I turn it on, does that help? Good job. Here, I'm going to turn it off. Practice again. Do you see it? Okay, now where's the Lagoon Nebula? Can you see it? You can actually see it on the program. Did you look up in this region? Good. You guys are doing so good. Okay. All right. Kent, what else should we look? Oh, did we look at M24?
I'm thinking M24 next because, you know, it's not like your typical open cluster or globular. It's just a bright section in the Milky Way. And the reason it's bright is there's no dust blocking it, or very little dust blocking it. So you're looking deep into our galaxy, or deep into the Milky Way. So that's why it's so bright. It's just this little bright section. It's not little. It's actually pretty good size. But you can definitely see it in your binoculars. And it stands out because there's very little dust there.
Awesome. Yeah, I've got it right here. And so this is where you want to look at it right above the handle of the, or not the handle, I'm calling it the handle too.
Yeah, you see, you know, it's actually kind of a hole through the dust into the deeper portions of the galaxy there.
It's so cool.
So you can see how it stands out for being bright.
Yes. Nice.
And so, plus you can see, you know, this is the telescopic view will show you a couple little dark nebula that are superimposed on M24. And also your handout was saying you get about 1,000 stars in your binoculars. So I know there's a lot there.
That's a lot. I mean, you got to be a kid in order to see those.
Yeah. Kids have good eyes.
They have really good eyes. Exactly.
But, you know, the thing to do is think about it's kind of like a hole.
Yeah.
You know, going deeper into the brighter, you know, bright section. There's a, you know, if you can remove all that gas and dust, that whole area would look so bright it wouldn't be funny.
So tell me, what else is in this area? I know there's a million different things, but what other couple ones can we look at with binoculars?
Neat binocular objects is on the western side of M24 is a nice little open cluster called M23. And it's about 2,100 light years away. And, you know, quite visible in binoculars. You know, usually I use M24 as kind of find M24 and then drift westward. That's it, westward. You come across the little open cluster M23.
Now this is above Lagoon, right?
Oh, pardon?
This one, it will be above the Lagoon Nebula if people are looking for it.
Actually, it's you go to M24 and it's west of M24.
Okay, perfect.
There you got it.
Yeah. Okay, great.
Yeah, that's a nice, you know, another nice open cluster. And then kind of just opposite on the other side of M24, on the eastern side, there's a really nice open cluster called M25. And it's about 2,000 light years away. The thing about M25 in the finder scope or binoculars, it has almost kind of like a spiral pattern. It's a really what should I say? The stars have a lot of variation in brightness, and it seems to make kind of like a curved spiral, if I remember correctly, when you're looking at it in binoculars.
Mm-hmm.
So it's kind of a nice, another, bright open cluster.
Nice. Okay, great. And did we talk about M17?
We haven't talked about the Swan Nebula yet.
Okay.
That's like the last one on our list, I think.
I think so. I think you hit all of them already. There's so many things. Why?
The Swan is Swan is one of the brightest, Messier objects for a H2 region. It's really where stars are being born. It stands out with an O3 filter, and with no filter, you can actually. It's kind of funny in my 8-inch. It looks like an upside-down wooden duck or a decoy duck. It has an elongated body and then a little curve for the neck, but everything's reversed in my C8, so it's upside down. Or I guess, up and down are okay. Left and right are reversed. But anyhow, it looks like an upside-down wooden duck is what I've called it for years. And it's also called the Omega Nebula. But it looks more like a swan than it does, like the letter Omega.
Mm-hmm.
And that area is loaded with young stars. Infrared, it lights up. So it's a definite star factory there, or a big star birth area. So, and it's, really nice and bright.
Yeah.
In fact, I think, what was my Mag 6 you had down there? So, yeah, it's definitely easy binocular object. Some people have seen it naked eye. Those folks with really good eyes that live in Hawaii or someplace, where the thing's like straight overhead.
Now, we didn't even talk about Mag 6, Mag 3, Mag 7. With binoculars, what's a typical range, would you think, that people can expect to see? I know it's.
We talked about that one time. I kind of forgot. But I think if you're getting around Mag 9 to Mag 10, you're starting to get down there. You're running 750s, 1050s. But I've never gone out and tried to see how faint an object I could pull in with a pair of binoculars.
But if you say something is magnitude like 6, could I expect to see it my binoculars?
Oh, yeah, easy.
Okay.
In fact, Mag 6 under dark skies and overhead, you'd probably be able to see it with your eyes. So
without binoculars.
Mag 6 will be easy. And the objects that we pointed out tonight, you should be able to see all of them real easily with binoculars.
Mm-hmm. Nice. Okay, great.
Oh, one other thing that we kind of didn't mention was, we mentioned the center of the galaxy, but also the bulge of the galaxy is right above Sagittarius and Scorpius. And you can actually see the dark lane that runs this time of year. You can see it really good, is the dark lane kind of runs in the middle towards Cygnus. So when you look at the Milky Way, you see a gap in it. They used to call it the Great Rift because they thought it was a hole, but it isn't. It's really our dust lane in our galaxy. So that's, can be easily seen this time of year when the Milky Way gets up nicely.
Mm-hmm. Let's see, you mentioned Cygnus. Let me kind of point out where that is here. Cygnus is all the way up here.
Yeah,
so,
Cygnus is up a ways.
Yeah, that's okay. It's almost overhead.
You can see the bulge of the galaxy. Actually, Antares is kind of sitting on top of the bulge in the diagram there.
Yeah. Now, we had a couple of questions about the Swan Nebula. One of them was, what kind of nebula is the Swan Nebula?
What sort of nebula?
Yeah, the question is, what kind of nebula?
Oh, for the dark nebulas?
No, for the Swan Nebula, for M17.
Oh, the Swan is an H2 region. Most of the red ones, like the Orion Nebula, the Swan that we're looking at, and like last month the Eagle. They're all H2 regions. Also they fall under the bright nebula category, but then they break that down into, there's also blue nebula that are reflection nebula from blue stars. And there's actually a whole mess of different types of nebulas. You got the bright ones, you got the dark ones, you got the planetary nebula ones, you got the supernova remnants. It just goes on and on.
It does. And you happen to know a little about that, don't you?
The planetary nebula, those are the ones I went crazy after. I've probably seen about, probably close to 7, maybe 800 planetary nebulas throughout the entire sky.
Wow.
Yeah, that's taken like 20 years to do that. So, but that's why I went down to Australia to look at the ones they had down there. And also I was able to see planetary nebula in the large and small Magellanic Clouds, which I think the large one's like 160,000 light years away.
Wow.
And the small Magellanic Cloud is 180,000 light years away. So those are way, way out there.
Yeah. Now, a planetary nebula, do you want to tell us about that? We're getting questions about why planets are involved.
Actually, it's kind of funny on the name planetary nebula. It's like a misnomer. Has nothing to do with planets. When William Herschel was looking at these nebula, he noticed that they were disc-shaped and they had a pretty sharp edge to them. They kind of looked like how a planet looked to him in his telescopes. But they didn't move, so they had to be some sort of nebula. So he basically called them planetary nebula based on their geometry. Being a round disk, somewhere elliptical, but they had like a sharp edge, kind of like a planet would. But they just sat there in the same place. And so we get to blame William Herschel. He's probably the best deep sky observer. He found like 2,500 deep sky objects. So he really beat out Messier. He's the guy right after Messier. But he gave the name.
Yes. We've had a number of people ask what the M means. Do you want to talk about him?
Oh, okay. Messier objects. Charles Messier was in the 1700s. He was a comet hunter. And he made up a nuisance list. There were these fuzzy objects, because he had really, small telescopes. And he'd come across these fuzzy objects, and he'd think it was a comet, but it wouldn't move. It just sat there. And like the first one in this list is Messier 1, which is a Crab Nebula, which is a supernova remnant. So he just, kept making his list and printing it. I think he did like 3 lists over his lifetime that he printed. And right now we have about 110 objects that we call Messier objects, but they're the nuisance objects. He really didn't care for them. He was hunting down comets. That was his important thing. But now everyone remembers him for his Messier objects. No one knows his comets.
I know,
so
everybody knows. It's so funny.
It turns out it's all the neat stuff, the neat open clusters, the neat globulars, the neat H2 regions, a lot of neat stuff, in its list. And so when you're an amateur and you get a telescope, you start going after Messier objects, because 110 objects, that's not too bad. And it's mainly for stuff in the northern hemisphere. They really didn't have a Messier for the southern hemisphere. Although there were people that went down south and found a few objects here and there. It turns out William Herschel's son, John Herschel, hauled a 20-inch telescope down to the Cape of Good Hope, and I think he found another almost 2,000 deep sky objects. So he really did a good job.
Yeah.
And they put it all together, his father's stuff and his stuff, into what they call the general catalog. And then later on, they had to revise it, so they came out with the new general catalog, or NGC. And I don't know if you've noticed, but a lot of these deep sky objects if they don't have a Messier number, they'll have an NGC object. We're still using the NGC catalog, even though they put it together in 1888. And so it's still like the catalog for, really neat deep sky stuff. But there's like 7,000 objects, so, most people won't live long enough to see all of those.
No, not at all. Awesome. So there's a couple other questions that have come up that have more to do with telescopes. And we have another question. What is a Caldwell catalog?
Oh, Caldwell objects?
Yes.
Oh, what it is, there was a British amateur astronomer, what was his name? But it turned out he wanted to make a list of objects beyond the Messier list. And so he used like his middle name, which was Caldwell. And so he just came up with these Caldwell objects. It turned out most of them were bright NGC objects that everyone knew by the NGC numbers anyhow. Some people love the Caldwell list. Some people hate the Caldwell list. But there are books out of Caldwell objects. And I just can't remember the guy. He liked to wear a monocle, believe it or not.
Patrick Moore. Is that who you were thinking of?
Patrick Moore, that's it. Yeah, yes. Patrick Moore. He did like a radio show for years on astronomy in England. And he did all sorts of books, that sort of thing. But yeah, my personal opinion is it just gives you another number to remember.
Yeah.
And I don't even try and remember the Caldwell numbers. I try and remember the NGC numbers or the names.
Right. There's already so many numbers to remember.
I mean, the thing is, anyone can make up a list and put their name on it. You could have the Aurora list.
Yes.
But the problem is, if no one remembers it, it all just falls into the dustbin of history and it's gone.
Yeah, especially when it's after the fact. I think Messier, he was one of the first to be doing that. And he was racing other people.
Oh yeah. I mean, Messier really didn't care about his nuisance list, other than it told other people there's a fuzzy thing there that looks like a comet isn't, and it won't move. So don't waste any time on it.
Right. It was his list of what not to look at.
Yeah, that's really, honestly, that's what it was.
And
was a list of those, if there's a fuzzy thing there and you'll swear it's a comet, but you'll spend hours watching it and it won't go anywhere.
That's true. So there's a couple of other questions. Oh, I should just mention there's a few people asking about the marathon. So astronomers run marathons, they're in really good shape. But it's all done by the telescope. So there's 2 weekends, I think. You guys can correct me. I think it's March is the best one, but there's also one for October in the Northern Hemisphere. Brian's nodding his head. Where you can actually see all 110 if you start right at sunset, and you should be able to see. March is the better one, especially for weather. Oh, look at you! Wait. Let me hang on. You're going on. Hang on. So yes, go ahead. That is the book.
Yes, this is the Messier Marathon handbook or field guide, and it's useful anytime during the year. But of course, we really want it during those times. And what's amazing is you're starting right as the sun is going down, and this book has charts that shows you gradients of how bright the sky will be, and you're working all night until the sun, just before the sun is coming up. And it's an excellent set of charts, even just to find all the Messier objects to use as you're learning the night sky. And it's really mostly based around using the Telrad, which gives you those 3 concentric circles projected on the sky, but he also has finder scope diagrams and sketches, so you have an idea of what to look for.
Awesome.
He's with Pomona Valley Amateur Astronomers in Southern California. So I'll post a link to this book in the chat.
Oh, that's awesome. Thank you, Brian. Thank you. And don't go away. You're coming back on in a minute here.
I'm still here.
Yes. So Brian has been tirelessly answering everybody's questions. So give him a big hand, everybody. Yay! Kent, there's a few more questions I was hoping you would answer. Are you up for a couple more?
Sure.
Okay, great. Okay, so the first question is, people are wondering, can I leave my telescope out, or do I always have to pack it up? You know, I want it out and available so I can use it on the back, you know, when I feel like it, but is it bad for the telescope? What's your feeling on that?
You know, I missed kind of it's something about a telescope and using something.
Oh, okay. Let me talk a little more clear. Sorry. The way we have Kent patched through, I don't know if you heard this, he's on a rotary phone. And so we've had to do a little bit of duct tape and baling wire to get him piped in to our presentation tonight. So sometimes he can't hear as clearly. So Kent, the question is, can I keep my telescope up all the time? Or is that bad for the telescope? Do I need to keep it in a case? Or can I just keep it out in the open?
You know, there's two things. As long as you aren't worried about it getting stolen, and you have a really good cover that goes over it to protect it from the wind, you know, and rain or whatever, you can keep it outside, you know, but you want to have the base secured so that a gust of wind doesn't knock the whole thing over.
Okay, what if you keep it up in your house? What about that? But just not in a case.
Then there's no problem. I mean, you want to keep the dust covers on everything, because otherwise you're going to be having to wipe dust off of, you know, the corrector plate or lenses. It's always good to have a cover over all the optics to keep, you know, dust will sneak in there no matter what. And so, yeah, it's fine to keep it on its mount inside the house. And, you know, it all depends on the environment inside the house also. If you've got kids that are fighting and running around and stuff like that you would think will trip over the tripod and crash the whole thing, then you might want to put it away. But otherwise, if, you know, there's nothing that'll knock it over like a big dog or something like that, there's no problem with keeping it upright and on the mount.
Okay, great. Perfect. And another question is, what kind of telescope do you recommend for, oh, you know what? I can actually handle this one because Kent, we did our homework in advance. So if you're looking for telescope, binocular, or beginning astronomy, taking photographs of things, equipment, look on your last page of your handout. We've actually put this together with links directly to websites. And so you can click on those. You can click on the original document before you print it out. So this is for you. So for kids, for grown-ups, binoculars, telescopes, and all of that. So your recommendations are already printed out for you. So yay! So don't forget to look at the last page. Other questions? Let's see. Other questions? Brian, let me bring you on. Do you have any other questions for Kent before we thank him and close out with more talk about the comet?
Oh, thanks, Kent. It's a wonderful presentation as always. I did just have one more question, but Aurora, I'm wondering if that might be one for you, if you're aware of a good stargazing app for kids that could help get them started in looking at the night sky. I recommended,
yeah, go ahead.
You know, of course, Stellarium for the program, but then do you know of an app?
That's a really good question. I personally use Sky Safari. I have an Android phone. When I was going through it, I downloaded like 10 of them, and I kept the one that I liked best.
That's what I use as well, because then it can, when you get the Pro, then you can lock it in with telescopes.
Yes.
Too.
Yes, and one thing that I would be aware of if you're working with kids is to make sure it's not too, how do you say this politely? Not too dumbed down and too like, I don't know how to politely say this, but like, and make sure it's not, it doesn't have like purple dinosaurs or something on it. You want it to be real at what they're learning. So like a real scientific instrument, so they learn that it's a tool and it's not a toy. And they also learn how to use it, especially at an early age. My daughter can tell you exactly what planets are up tonight just using a wall chart that we have that astronomers use because we've taught her how to do that. So like I wouldn't give my kid a measuring tape with like, you know, hearts and flowers all over it. I would make sure the measuring tape could measure something. Does that make sense? So that would be my recommendation. Just give kids and give them the instruction that they need with it. It's, again, not a toy. It's something that you would want to use. There is overkill, right? You don't want the one that's too difficult and you just give up on it. But But I like Sky Safari because you can click on tonight's best and it'll give you a tour and you put it up and then it'll say, okay, now make it go more this way. Okay, make it go a little this way. Okay, there it is right there. And then you take it off and you look in that same section of the sky and you put your binoculars up to your eyeballs or naked eye, and you'll be able to see what the app is telling you. So, how's that?
Well, hey, Aurora.
Yes.
This is Ken. I got a question for you.
Oh, yes.
You have the H.A. Ray. You have the H.A. Ray book
I
sitting
do.
around there?
I do. Look at this.
You know, I was thinking maybe you can show folks how simple that book looks.
Okay.
It
Yes.
looks like it's made for like second graders, but it's really the easiest way to learn the constellations that I've come across.
So tell me, who is this author? Is this anybody people would know? Who is the author of The Stars, Kent? Who is that guy?
H.A. Ray
Yes.
is the author of The Stars, A New Way to See Them.
And what else
And
did
you can
he
see
write?
how I mean, that looks like he did the Curious George books, all
Yeah.
the Curious George books. That book was produced in 1952, and you know, I still pull the thing down and use it at times.
So this is a good resource, especially if you've got kids and you want to start learning the constellations. There's nothing that beats an old book because you can write your notes in it. You can dog-ear pages. Sorry, English teachers, I do that. And you can really make this your own. And as Kent said, 50 years later, you could still pull it out. Try that with an app. But you can definitely do this.
And the thing is, it's still in print after all these years.
Yeah, that tells you something, doesn't it?
Yeah, the thing I like also is it has extra beyond the blue area there. So it has lots of overlay from the main constellations.
Yeah, definitely. Great. All right, Kent. Well, I thank you so much for being with us. Go ahead and take your typing fingers out and drop Kent a note. We actually copy and paste all of these comments and give them to him. So if you enjoyed tonight's presentation, just let him know. Just drop him a note. Put it in the comment box right now. Tell him what you enjoyed most, what you really, anything that you really appreciated about tonight's presentation. So while you're doing that, Kent, I just want to extend my personal thank you to you after so many years of knowing you and doing stargazing together with you. It's always such a pleasure. And thank you for sharing your knowledge with everybody.
Well, thank you, Aurora, and thanks for doing all the hard work. I just sit here, I'm like a disembodied voice.
I know.
You're doing all the hard work there.
Oh, it's really no problem. It's my pleasure. You're the one who did the hard work all those years with the telescope and lifting and shipping. So now it's my turn. So I'm totally happy to do that. So.
Okay, thank you very much.
You're
I'll
welcome.
go now.
Thank you, Kent.
See
Have
you
a good
later.
night.
Thank you. Bye.
Bye-bye.